All right, welcome back. Mr. PL's with Geometry. This is Unit 1, Topic 1, Lesson number 6. And this time we're going to be in writing terms in order to describe the illustration and vice versa. And here we go. So we're going to start off with talking about collinear, something we did already talk about in a prior video. Collinear literally means in a straight line. Use the figure and name a line containing point K. So if I name a line, there's a couple of ways I could do that. I could say line JL. Or I could literally just say line A, because line, it's a lowercase, so that's the name of the line. That is not the name of a point. B says use the figure to name a plane containing point L. So there's a couple of ways to do that. I could say plane B, or I could name 3 non-collinear points. So I could say, now keep in mind, B is the name of the plane, and I know that because it's in italics, or I could say plane JKM. Now, the only thing you can't do here is you can't say plane JKL. And as I had mentioned in a previous video, if you think of like this notepad right here as the plane, that everything on this notepad is on the same plane, or anything, you know, in all directions. If you have 3 points out here in the middle of space, I could turn this, and I know this is a very hard thing to imagine, I could turn this plane in any direction and still be going through those 3 points that I drew on the paper themselves. Whereas if you have 3 points that are not collinear, you can't bend the plane to hit another point, because planes have to go, you know, in opposite directions of each other. So they have to be non-collinear. So I could have chosen JL and M, and there's plenty of different choices, or KL and M. As long as the 3 points are not in a straight line, it works. All right, so it says draw a picture of 2 lines, F and G. So once again, we're drawing illustrations of what we are being described in words. So draw a picture of 2 lines, F and G, that intersect at point P. So let's call this line F, and it's very important that you focus on the terminology that is given. It does say lines F, so you do need to have arrows, and this is line G, both lowercase, and that intersect at point P, uppercase P right here for the point of intersection. Number 2 says draw a picture of 3 parallel lines A, B, and C with a perpendicular line T intersecting them. All right, so 3 lines, we'll call this one A, we'll call this one B, and I'm going to try to make them look parallel, but honestly, looks doesn't really matter, honestly. And then we've got one that's perpendicular, and we do need symbols. So we've got perpendicular line T, and we've also going to put that parallel symbol for both A, B, and C. So remember, it's all about the notation that proves what it is. Just because it looks parallel doesn't mean it's parallel, but having that symbol, that proves that it's parallel. Draw a segment with endpoints, J and K, okay, capital letters. Draw line R, the perpendicular bisector, okay, so line R will be right here, lowercase r, perpendicular bisector, okay, perpendicular and bisector. So now the fact that it's a bisector means that it splits JK in half. All right, and there we go. Question number 1. Now we're doing kind of the opposite. I know we've reviewed some. This is basically a review of what we did 2 lessons ago, or 2 videos ago. Give a description of each picture using academic language and incorporating any appropriate vocabulary words as possible. All right, so I'm not going to be writing everything I say because there's just a whole lot to write, so I'll just describe my way through it. So we've got BC is perpendicular to DE segments, right? And we've also got, 2 lines, DE and DC, that are perpendicular to each other. We've got points D, F, and E. I guess I don't need to say that because I've already said that. I can say F is at the intersection of line B, C, and DE. So really that says everything right there. Sorry, I might have confused you. So basically all you really need to say is that DE is perpendicular to line DE is perpendicular to line BC, okay, and that they intersect at point F, and that's everything. So over here we have line KL is parallel to line MN, with O also being on line MN, and P being in space in between the two parallel lines. Now, I know it doesn't tell you exactly where it's at, but there's really no way for us to describe exactly where it's at in this case. Number 3, so we've got angle ABC is an acute angle with point E inside of the angle and point D outside of the angle. Number 4, we've got line segment PQ with point S on that line segment, but closer to P than Q. And we have point R is out in space on the right side of the segment. If I said line a second ago, I feel like I might have said line. Ignore that. I meant to say segment. All right, so what do we see in these figures? I'm going to have to move myself here. So we've got, we don't know the name of the plane. So on a plane, I don't know the name of the plane, so I'm going to have to say plane ABE, right? And there's no letter for the name of the plane. What I mean is I'm going to have to name it by the points. I just have to choose any 3 points that are not collinear. They're coplanar. They're on the same plane. So we've got 2 lines. Line P and line Q are on plane ABE. The 2 line P and Q are parallel. I should have said that. Line P and Q are parallel on plane ABE. And point B is on line P. No, points A, B, and C are on line P, and points D and E are on line Q. If I was going to describe this one, I would say we have 2 intersecting planes, which intersect on line R. This is the line of intersection for 2 planes. Now, 2 planes will always intersect at a line, whereas 2 lines will always intersect at a point. And that's only because we have two-dimensional hitting each other makes a line for its point of intersection. For its line of intersection in this case, sorry. So we've got plane N and plane M. It's kind of hard to tell that those are italicized. That are intersecting at line R. And we've got points G, J, and H and K, sorry, are on plane M. We've got points F and L, which are on plane N. And H happens to be on the line R. I think that's pretty much everything that's there. A little tricky one to describe. So we got 2 more here. Then we got lines R and S are parallel with, okay, this is a new word here. So we've got a line intersecting those parallel lines. That is called a transversal. A transversal Q is going through point R at, going through line R at point A and going through line S at point B. And then I would also say that point C is also on line Q, but below point B. All right, here we have a plane QRS, okay? And it looks like both line M and line N go through plane QRS through point Q. Now, these dotted lines are supposed to show that the line is going through it. It's not on it. It's supposed to be like underneath of it. That dotted line means this line is going through the piece of paper. It's like poking a pencil through a piece of paper. This line is going through the paper, and then what's underneath in dotted line is what you can't see because the paper is in your way from seeing it. And that would be figure 4. All right, so just a couple more of these, and that'll be a wrap. So this one over here, so we have a triangle formed from lines C, A, and T with line B perpendicular to line T, but going through point G, which is the vertice of the triangle, which is the vertice of the intersection point for A and C. So there's a lot going on. This might look like a pretty simple diagram, but it's got quite a lot going on here. I would also say that point H is the point of intersection for lines C and T, and point K is the point of intersection for lines A and T. All right, over here we've got plane UVT has two lines, line UW and line TV, which are perpendicular of each other. And V is at the point of intersection of the two lines. All right, so down here, figure number 7, I would describe this as 3 parallel lines, G, H, and J, being cut by transversals E and F going opposite directions, but intersecting line G at point A. And lines E and F intersect line H at points A and C, and they intersect line J at points D and E. Now keep in mind, this is the way I would describe it. There's going to be other ways to describe these diagrams. So however you come up with it is your choice. So here we have plane XYU with a line on the plane, line XZ, with point Y in between points X and Z, where another line is intersecting point Y, but is not on the plane. And that would be line WV. Also intersects point Y, like I said a second ago. And then one last thing I would say is point U is out in space on the plane. It's in the plane. All right, I think that pretty much wraps it up. Have a wonderful day, and I'll see you in the next video. And please give it a like if I helped you learn how to do these describing the diagrams using our terminologies. Terminologies have become very important throughout this year in geometry. Have a great day.